Right, so it's April 13th, 2015, and this is a practice speech on the affirmative side for the upcoming Feingold public debate. Question is, should gain-of-function research on potential pandemic pathogens be prohibited? You want to move this down a little bit?
Sure. That might be a little more comfortable for you.
Second. All right, Swati Raj first time through from A to Z, soup to nuts. Good luck.
Good afternoon, everyone. My name is Swati Rajprahat, and before we begin, I would like to start by thanking you for the opportunity to debate today. My partner, Dr. Mark Lipsich, and I stand in firm affirmation that gain-of-function research on potential pandemic influenza pathogens should be prohibited. We would like to preface by defining a few key terms. Gain-of-function research in this context is defined as the research studies on avian influenza viruses that may lead to increased viral transmission, virulence, and novelty in humans. The combination of characteristics will allow the virus to be readily spread from human to human on a large scale with little to no immunity towards the virus. This creates a deadly amalgamation of diseases that will be difficult to fight once outside the laboratory setting. Now imagine yourself as a scientist working in a lab, expecting a package from your coworkers from another university. To your knowledge, this package contains the inactivated form of a deadly virus you and 75 other members of your lab need to work on. You get this package and start working with the virus. And because it is inactivated, you use minimal safety precautions. A few days later, you get the notification from your coworkers that this virus that you've been working on was actually was actually not inactivated. The wrong vial was sent to you, and now you and your coworkers might be infected with this lethal strain. Scary? Unfortunately, this situation actually did occur last year in June involving anthrax. The scientists were given antibiotics and treated accordingly. But imagine this same situation occurring with a much more pathogenic virus with high transmissibility and absolutely no vaccine to mitigate the effects. The outcomes can be debilitating, not only for the scientists, but for you and your families as well. Flu strains are more pathogenic and easily transmissible. The question remains, what would you do in a deadly situation like this? Unlike anthrax, this flu virus is very hard to control, which is why we are discussing it today. The goal is to prevent anything like that from happening in the future. The foreseen purpose of this research is essentially to create a novel virus to study the potential of genetic diversity and its associated phenotype. This type of research is currently under intense debate in Washington and has been put to a halt since October of 2014 due to its perceived dangers of biosafety and biosecurity. The debate essentially boils down to a cost and benefit analysis. I think my opponents and I would both agree that the advancement of scientific knowledge and preventing pandemics is the universal goal. The best way to go about it has become controversial. Looking at the imminent harm of GOF research studies, however, the answer lies in halting to potentially save many lives. There are three main reasons to do so. Our first point of contention is that the probability of risk of releasing a novel virus from the laboratory is high enough to have the potential to kill 20 million to 1.6 billion. This is the thorough risk analysis of probability and consequence, and larger than any pandemic we have experienced. This is the risk data presented by the National Institute of Allergy and Infectious Diseases and is generated based on analysis of Biosafety 3 laboratory containment. The estimates of these risks, admittedly, are imprecise due to reporting and other factors. However, the point is that there is still a risk. Imagine you have a box of brownies and you are told that there is a 0.1% chance that one of the brownies is poisonous. Are you going to take the chance and eat that brownie? Most people would say that they would not. They would avoid the risk altogether. Currently, GOF studies are being conducted in BSL-3 enhanced laboratories, which are to be used for viruses that may cause lethal diseases through inhalation. They have advanced filtration systems, double doors, clothing and body protection and requires specific training. This is in comparison to some other virus research facilities like smallpox that use BSL-4 safety standards. These safety standards are used for viruses which are very dangerous and pose high risk for aerosol transmission and may cause life-threatening diseases whose pathogenicity is uncharacterized, and those viruses that don't have any vaccine or treatment. Does this sound similar to the viruses that are being created in GOF studies? There seems to be a clear misstep in the regulation of avian flu GOF research and the facilities that the research is being conducted in. This shows that there is a fundamental misunderstanding for the danger of these viruses created by GOF. Without significantly hindering the possibility of this type of virus to reach the public, there will always be a threat to release it, especially in the containment facilities it is currently in. This is the difference between those viruses that pose an occupational health risk to the workers versus a virus that creates a public health safety concern. Most of the viruses that are being currently investigated have low transmissibility with other workers and humans. In fact, a lot of viruses don't have transmissibility in humans at all, such as the Ebola virus. But the flu virus is different in that sense that it can spread from human to human on a very large scale. We are not asking to curtail the research on all dangerous pathogens, and this is a really important point to make. We are asking to curtail those that are just concerning the public. Our second point of contention is that precise genetic understanding of virus is not necessary to create successful vaccines. In fact, according to its proponents, the reason for conducting GOF is to better understand dangerous phenotypes, to better characterize its phenotypes for vaccine creation and overall addition to scientific knowledge. The fact of the matter is, however, that the predicted phenotypes of these genes are not that easy to predict and are often inaccurate when placed in a functional setting. Some examples would be when oseltamivir, the flu medication, was being studied during its first research phases. There were differences between what was being researched and how it was actually being functioned in actual human settings. And there are many more examples of the such. To conduct GOF studies with the hopes that will be accurate prediction of what the virus can do and how to control it is simply not right. There are other research methods to have similar effects and gain of knowledge, but without posing that public safety health risk. These alternatives include using defective viruses, targeted therapeutics, and accelerate vaccine production and more. And this is according to Dr. Lipsich's own research in collaboration with Dr. Galvani from Yale University. Our third point of contention is that of ethics. The question of ethics, though we like to avoid it in a debate setting due to its foggy character, it cannot be avoided while discussing a topic as applicable as public health. The main code of ethics for researchers conducting work for human subjects is known as the Nuremberg Code. This code summarizes that research should create fruitful results and cannot be obtained by any other method. And we have seen that there are indeed alternatives, effective alternatives, that we have been using for many years in the past that can have similar outcomes as gain-of-function studies that don't pose this immense threat to public health. It also implies that the research should be wholly applicable to humans and not for simple gain of knowledge. In addition, scientists have no obligation to do harm to the public, and even an ounce of harm, even a small chance that there is a risk that 20 million to 1.6 billion people may be affected by a simple laboratory accident, I'm not sure if this is a risk that we are willing to take. Thus, any research that even has a small chance of inflicting something that as large as a pandemic to the public should be seriously contended. In conclusion, my partner and I believe that the risks in this case largely outweigh the benefits. There is simply too much of a physical risk, speculative and ethically charged, to put the public at risk of any of the consequences of laboratory accidents concerning novel, highly transmissible pathogenic flu viruses. While both the risks and the benefits of this research are marginal and speculative, it can be said that the marginal risks outweigh those marginal benefits. Both sides share the goal of public health safety from dangerous viruses, but it's best to work together to limit these risks altogether. Thank you.
About the same, actually.